Hello, in this video we're going to talk about properties of matrix addition as well as matrix multiplication. But let's start with some of the properties of matrix addition. So there are 5 properties that I'd like to overview here. We've got the commutative property, so you can add matrices in either order. A plus B is the same as B plus A. Matrix addition is associative, so you could associate the A and the B together and add those first, then add C, and that would be equal to the result of adding up the B plus C first and then adding the A. There is an additive identity, it's called the zero matrix, and I've put it in the equation here as a big zero. So A plus the zero matrix is the same as the zero matrix plus A, and that just gives you A. We have distributive properties for scalars. So if R is a real scalar, R times A plus B is just R times A plus R times B. And similarly, if you have another scalar S, so R and S are real scalars, you've got R plus S times A. That's just equal to R times A plus S times A. And lastly, we've got an associative property for the scalars. R times S times A is equal to R times S in the real numbers times A. So let's take a look at an example. In our example here, let's find 3A minus 5B for the matrices A equals 1, 2, 3, 4 and B equals 0, 1, negative 1, 2. So 3 times A, let's write this down. 3 times matrix A, which is 1, 2, 3, 4, and then we have a negative 5 times matrix 0, 1, negative 1, 2. If we work this out, let's see what we get. Well, the first matrix here, multiplying by the scalar 3, we're going to get 3, 6, 9, and 12. And next we have a 0, 5, negative 5, and 10. And subtracting those matrices, we get a 3 minus 0, so component-wise subtraction. We have a 6 minus 5, which is 1. Down here we get a 9 minus a negative 5, so that's 9 plus 5, that gives us 14. And we get a 12 minus 10, that gives us 2. Okay, let's take a look at some properties of matrix multiplication. So matrix multiplication is associative. It is also distributive. We have a multiplicative identity, which is denoted by I, and sometimes you'll see this denoted by I sub n. It's an n by n identity matrix. And lastly, matrix multiplication, we've got associative scalar multiplication going on. So if you have a scalar R times the product AB, that's the same as R times A times B or A times R times B. And this is really helpful because it allows you to essentially pull scalars out in front. So let's take a look at an example here. Let's simplify the following. So let's simplify the following. We've got matrix A times A minus 3B plus 2B, 3A minus B. We've got a minus A squared plus a 6B squared minus 4AB. Okay, so what are some things we can do? Well, first of all, we can multiply A times A minus 3B, and that's using our distributive property. So let's use that here. We get A squared, A times A is A squared, and now we get negative A times 3B. Similarly, let's use that distributive property over here. We have 2B times 3A, and we have a 2B squared, and I'll just copy down the rest of the equation. Now, it looks a little awkward the way I've written this here because we have a scalar in the middle of our product of two matrices, so let's use this last property, property 4, and pull those scalars out in front. So let's do that. We have A squared minus 3AB. Pulling scalars out in front, we have a 6B times A minus 2B squared, just copying down the rest of the problem. Okay, so notice in general that matrix multiplication is not commutative, and we'll show that in another video. And for that reason, I'm not allowed to combine any of these terms, right? Because A times B is not necessarily the same as B times A. So we cannot combine those sorts of items. But we do have a couple of A squared terms here. So we have an A squared and a negative A squared. Those will cancel out for us. And we do have a couple of terms of the form AB. So let's see, we have a negative 3A and a negative 4AB. That'll give us a negative 7AB. And we have a couple of terms of the form B squared. That gives us 4B squared. Takes care of those. And the only piece left over is a 6BA. And that's the best we can do for simplifying this expression.